Hi! In today's tutorial on periodic perfection, we're going to be talking about electrolytic cells. Now, an electrolytic cell is different from a voltaic cell. A voltaic cell makes its own energy. It uses chemical energy to make electrical energy. But in an electrolytic cell, we are using energy to force a chemical reaction to happen. And that is why we need a battery. Without a battery, this type of reaction won't work. So let's talk about the setup. We're going to do a little labeling. This goes along with your notes. If you look at our electrolytic setup, we have our anode and our cathode, just like in a voltaic cell. But in this cell, our anode is going to be made out of nickel, and our cathode is going to be made out of zinc. So let's take a moment and look at table J and see how that relates to our system. So here, our zinc, which is on our cathode, is here, and our anode, which is nickel, is there. Now that sounds weird. Our nickel is lower than our zinc, but our nickel is our anode and our zinc is our cathode. How is that supposed to work? Your anode is supposed to be higher. Well, in an electrolytic cell, we use the battery to force this reaction to happen. It's non-spontaneous. So our anode can be made of a metal that is less reactive than our cathode. You'll notice that we have a single cell. We don't have two separate cells that we're looking at. This single cell has one solution in it, and in this case, our solution is molten sodium chloride. This is actually how we can generate solid sodium and chlorine gas in a chemical system. Coming back to our diagram, our anode is still our site of oxidation. Our cathode is still our site of reduction. That has not changed. The one thing that is different here, however, is in this cell, our anode is going to be positive and our cathode is going to be negative. And the reason why, it's all about the battery, and it has to do with how the battery is installed. Have you ever put in a battery the wrong way into an appliance like a calculator or a flashlight and it didn't work? That's because the battery has to be specifically installed so that the positive pole of the battery and the negative pole of the battery are facing the proper direction to create a supply of current. In our electrolytic cell, it's very important that the positive end of our battery be closest to our anode and our negative pole of our battery be closest to our cathode. Because if you remember that old rule of opposite charges attract, you'll get the picture of this pretty quickly. This positive charge on our battery actually serves to pull electrons off of our anode. Those electrons would not come off on their own. They are literally pulled toward the battery because the electrons are negative and this end of the battery is positive and the opposite charges attract. Here we have a negative charge on our battery. So once the electrons move through the battery in this direction, now they're going to be repelled by the negative end of the battery. And they are going to be pushed toward our cathode where they start to build up, where reduction starts to happen. What is it that happens? Well, our sodium ions get attracted to our electrons. They're positive, our electrons are negative, and we are going to get reduction of those sodium ions here at the cathode. So you're going to get a buildup of solid sodium on the outside of the cathode. Likewise, here, the negative chlorine ions are attracted to our anode, which now has a positive charge because we've been stealing all its electrons away. So every electron that moves away, we get a little more positive over here. Because our anode is positive, the chlorines are attracted to it. This chlorine gas can be evolved off, it can be captured and put into a tube and then used for industrial purposes. When this finishes running, this solid sodium can be scraped off and isolated. That is the basic of an electrolytic cell. Once again, an electrolytic cell won't function without a battery, and the reason why it works is the positive end of the battery attracts the negative electrons and then pushes them past the negative end of the battery onto the cathode. If the battery were not there, the entire system would shut down. That's it. Very simple.